Hey everyone, this is going to be my video walking through the Chapter 5 exam. This is not meant to be an instructional video per se, teaching all these concepts, but to show you how to work these problems, work them out in front of you, remind you of some things. So while I might not go as in-depth into the teaching, I'm hoping this will be useful showing you how to correctly work these problems. So we'll just jump right in. Number 1, state the y-intercept, vertex, and axis of symmetry for this function. So I know I'm going to start with my axis of symmetry. And we find the axis of symmetry by using the equation x equals, it's a vertical line, negative b over 2a. So plugging in our values, that would be negative 10, there's my b value, over 2 times negative 5. So x equals negative 10 over negative 10, which means x equals 1 is my axis of symmetry. So vertical line, x equals 1. From there, we can find our vertex, because if you recall, our vertex has to be on the axis of symmetry, meaning we know the x coordinate. So it's 1 comma something, and if we plug 1 into our function, we'll find the y coordinate. So f of 1 equals negative 5 times 1 squared plus 10 times 1 plus 2. So negative 5 times 1, order of operations, plus 10 plus 2. So negative 5 plus 12, which equals 7. So my vertex is at 1 comma 7. Vertex 1 comma 7. And then the y-intercept, if you will recall, is simply where do we hit the y-axis? And if you remember, that means the x-coordinate by definition is 0. So f of 0 equals negative 5 times 0 squared plus 10 times 0 plus 2. And as you're working this, you might remember, oh yeah, it's always that c value. It's always just going to be, because the zeros cancel the x's out, in this case 2. So you could put 2 here. I'm going to put the full point 0 comma 2 for our y-intercept. And we are done with problem 1. Problem 2, circle whether f of x has a maximum or minimum value and find that value. I know that this f of x has a maximum value because the a value is negative, meaning we are opening down, meaning we have a highest point, but it goes down forever, so not an absolute lowest point. And so I can just circle maximum right off the bat. Now from this sketch, you might remember, okay, that maximum value is the y-coordinate of the vertex. So I need to find the vertex. I'm going to do kind of exactly what I did before. First, find the axis of symmetry to find the x-coordinate. So x equals negative 6 over 2 times negative 3, negative b over 2a. So x equals negative 6 over negative 6. Hey, it's x equals 1. Again, for my axis of symmetry. And that means that my vertex is 1 comma something. And I will plug 1 into my function to figure that out. F of 1 equals negative 3 times 1 squared plus 6 times 1 plus 1. Negative 3 times 1 plus 6 plus 1. So negative 3 plus 7 is 4. So the vertex is at 1 comma 4. And so the maximum, you will often see it written just the y-coordinate, because the maximum is what is the highest point we got to. So I could say 4. I'll go ahead and include that entire point 1 comma 4, knowing that it's really that 4. That is my maximum. All right, solve this next one by graphing. So to graph, I want to make sure that I get everything on the same side of the equation. And so I'm going to move everything to the left. X squared minus 6x plus 8 equals 0. Find the graph. Let's do axis of symmetry. X equals negative negative 6 over 2 times 1 for my a value. 6 over 2, x equals 3. So it says solve by graphing. That means we probably should put a graph there. And x equals 3 is my axis of symmetry. Perfect. Let's find our vertex now. It's becoming a theme. The vertex is going to be at 3 comma something. So I'll just plug it in and we get 3 squared minus 6 times 3 plus 8. So 9 minus 18 plus 8 would be -1. 3 comma -1. That is my vertex. Now it says solve, and solve, remember, means find where we hit the x-axis, find the roots. So I'm going to make a table, and I'll go ahead and do this maybe over here so we can see it. I know that 3 comma -1 is my vertex. So I'll plug in maybe 4, 2, 1, 5. See if I can find where we hit the axis. Luckily, we're pretty close to it right now. If I plug in 1, I would get 1 squared minus 6 times 1. So that's -5 plus 8 would be 3. Because of symmetry, I know it's also going to be 3 when x is 5. Let's try plugging in 2. So 2 squared would be 4 minus 6 times 2, -8 plus 8, it does equal 0. And so this is what my parabola looks like, just about, if I can hit those points. But what are the solutions? X equals 2 and 4, where I hit the x-axis. Those are my roots. So 1 through 3, lots of graphing. How about number 4, solve by factoring? I know that the first stage in factoring is make sure everything equals 0. So I'm going to move some stuff over. So 5x squared plus 13x minus 6 equals 0. And because I have that 5 as my a value, and I can't pull it out, it doesn't go into everything, this is going to be a grouping problem. I know I've got my 5x squared. I know I've got my minus 6 equals 0. But let's find our 2 numbers that we need to break b into. So need to multiply to be a times c. So it needs to multiply to be -30, add to be 13, just b. And so what multiplies to be -30 adds to be 13. 10 and 3 is the tempting choice, but they would have to have opposite signs because it needs to multiply to be a negative. So 10 and -3, that'll just get me to 7 or -7. How about 15 and -2? Those multiply to be -30, add to be 13. So I'm going to say plus 15 x's minus 2 x's. And then I'll group. Pull a 5x out, x plus 3. Pull a -2 out, x plus 3. Still equals 0. So my 2 factors are 5x minus 2 and x plus 3. Now, because we're asked to solve, we need to find the actual x values that make this true. So if you remember, we're going to go 5x minus 2 equals 0. What would make that equal 0? If 5x equaled 2 and if x equaled 2/5. So there's one answer, 2/5. My other answer, what would make x plus 3 equal 0 if x were -3? So -3 or 2/5 seem to be our solutions solved by factoring. All right, simplifying complex imaginary numbers. Square root of -100. Recall that my first step is, if I see a negative in there, I'm just going to pull out an I, and it becomes square root of 100. Then I can break that down using a tree, or I might just recognize, wait a second, that's just 10. Square root of 100 is 10, plus or minus 10, and then the I that we took out. So plus or minus 10i. What about this next problem? Number 6. Adding complex numbers, we just combine like terms. So 6 plus 12 is 18. Negative 5i's plus 7i's is plus 2i. 18 plus 2i. Now, number 7, this is kind of a foiling one with complex numbers. So 10 times 4 is 40, plus 10i minus 12i minus 3i squared. So 40 minus 2i, if we combine those. And then remember that I squared is negative 1, right? We always want to simplify that. So we get minus 3 times negative 1, which is really a plus 3. 43 minus 43 minus 2i. All right, last problem on this page, number 8. How do we divide by a complex number? Remember, we don't want radicals in the denominator, and that I is a radical. It's the square root of negative 1. I'm going to multiply by the complex conjugate of the denominator, 2 plus 3i. So flip the sign of that I part. That means on top, I'm going to get 4i plus 6i squared all over 4 plus 6i minus 6i minus 9i squared. Well, that's going to be 4i minus 6, right? I'll go ahead and do that now. That's a negative 1, and that's a negative 1. So 4i minus 6, because it's 6 times that negative 1, over 4 plus 9, because that minus 9 times negative 1. So 4i minus 6 over 13, and then we'll break it up. 4 over 13 i's minus 6 over 13. And for my final answer, I'll just write it in that traditional complex number format with the real part first. I'll say negative 6/13 plus, it was a plus, 4/13 I. So that's our front page, and there was a lot in there. If you look at the number of problems, it was almost half the test, but some graphing, some factoring, and lots of complex operations. Let's move on to number 9. Write a quadratic equation with negative 6 and 3/4 as its roots. Make sure that a, b, and c are integers, and you write it in standard form. If I know negative 6 is a root, that tells me that x plus 6 was probably a factor, because that's what would get me negative 6 as a solution, as a root. And kind of similarly, if I can grab my blue marker, if 3/4 is a root, that means x minus 3/4 was probably a factor. So I can FOIL this out, and then I'll have it in standard form. But one thing I notice is I want a, b, and c to be integers, and I already have a fraction in there. That's not looking that promising. It could work out, but I might have to adjust it, something to keep your eye on. You could do it now. I'm going to save it till the end. So what I'm going to do is I'm going to FOIL x times x, x squared, minus 3/4 x, plus 6x's, minus 18/4. And yeah, it's looking like we're going to have some fractions. And maybe you're not feeling super confident on the fractions right now. If that's the case, what can we multiply on both sides of the equation to get rid of those fractions, the denominators? Let's multiply both sides just by 4. I know that 4 times 0 is still 0, so that side's fine. Here I have 4x squared minus 3x, because that 4 we're multiplying by will cancel with the 4 on bottom, plus 24x's minus 18. So final answer, combine your like terms, 4x squared plus 21x minus 18 equals 0. 4x squared plus 21x minus 18 equals 0. All right, completing the square. We're going to get some plus blanks going here. So on this first one, number 10, I'm going to say that x squared minus 6x is equal to negative 13. And I'm going to leave some room for a plus blank plus blank. Let's make this a perfect square. That means I need to add b over 2 squared to both sides. I need to add 9 to make this a perfect square. And so that, if I'm writing it as a perfect square, I can factor it. It's x's, it's minus, x minus 3 squared equals negative 4. Let's take the square root of both sides. That should have been blue. My apologies. I accidentally got rid of one of my red parentheses. Okay. X minus 3 equals, what is the square root of negative 4? Well, square root of negative 4 is equal to plus or minus I root 4 plus or minus 2i. So plus or minus 2i, I'm going to get rid of that just so I have room for 11. X equals 3 plus or minus 2i. So making a perfect square so that we can then use that square root property, just take the square root of both sides. Same process on 11, just a little bit trickier. We can only complete the square if we have x squared, just one x squared. So I'm going to divide everything by 2 straight away. X squared plus 3 halves x minus 1 equals 0, dividing everything by 2. So let's do the same thing now. X squared plus 3 halves x is equal to 1 plus blank b over 2 squared is what I need to add. 3 halves divided by 2 is 3/4, and you can check me if you want by copy dot flipping those fractions, 2 over 1 on bottom. I need to add 9/16, it looks like, to both sides. So what is my perfect square on the left? If you recall, it will always be x, and then whatever we got when we did b over 2. We got positive 3/4, x plus 3/4 squared equals, and then what is 1 plus 9/16? Well, that's 16/16 to get a common denominator, so 25/16. And that actually is going to work out really well because both of those are perfect squares, which is convenient right now. X plus 3/4 is equal to plus or minus square root the top, square root the bottom. So x equals negative 3/4 plus or minus 5/4. X equals negative 3/4 plus 5/4, so 2/4, or negative 3/4 minus 5/4, negative 8/4, which means x equals 1/2 or negative 2. And I'm going to write them just in ascending order, negative 2 or 1/2. Those are my two answers. All right, let's go on to 12. Now we're getting into 5.6, quadratic formula. Solve using the quadratic formula. To do that, I need everything on the same side. So 5x squared minus 3x plus 2 equals 0. And then we know the quadratic formula. We can sing it. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Pop goes the weasel. So that means that in this problem, x equals negative 3 plus or minus square root of negative 3 squared minus 4, 5, 2 all over 2 times 5. Just plugging them in and let's simplify. X equals 3 plus or minus the square root of 9. 4 times 5 is 20, times 2 is 40, 9 minus 40 all over 10. X is equal to 3 plus or minus root negative 31 all over 10. And typically we would simplify that and just pull the I out. 3 plus or minus I root 31 over 10 for my solutions. 31 is a prime number, can't break that radical down. x equals 3 plus or minus I root 31 all over 10. Okay. 13 is also quadratic formula based. A, find the value of the discriminant. B, describe the number and types of roots. So I'm going to get everything on the same side. And I'm going to write them in my descending order, A's, B's, and C's. 9x squared minus 12x plus 4 equals 0. If you remember in the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. The discriminant is the part inside the radical. So the discriminant is equal to b squared minus 4ac, or negative 12 squared minus 4 times 9 times 4, 144 minus 4 times 9 is 36 times 4 is 144. The discriminant is 0. And you may recall that actually tells us something really significant, because if we're plugging that in here, negative b plus or minus the square root of 0, square root of 0 is just 0, plus 0 minus 0 doesn't make a difference. There is going to be one real root because the discriminant is 0. All right, number 14, we're 5.7 now. 14, not too much math calculations to do. We're just interpreting. We have this equation in vertex form, and I'm going to write that down below. We're asked for the vertex. That is our h comma k values. So h, whatever would make those parentheses 0, so negative 5, and k, whatever is on the outside, negative 7. We know that the axis of symmetry goes through the vertex, so it has to be the same as the x coordinate of the vertex, negative 5. And because a is a negative value, we know that this opens down. So 14, simply interpreting what we have here. What about 15? 15, write an equation in vertex form. We're given the vertex and we're given another point. So vertex form, y equals a times x minus h squared plus k. Step 1, let's plug our h and our k in. So our vertex was negative 4 for the x, positive 2 for the y. So that gives me y equals a times x plus 4 squared plus 2. And then to solve for a, we're going to plug in the other point. Negative 7 equals a. Sorry, I'm going to color code this. Negative 7 for the y, 2 for the x. I'll put those in blue. Negative 7 equals a times 2 plus 4 squared plus 2. Subtract the 2 over, we get negative 9 equals a times 2 plus 4 is 6 squared, 36. Divide by 36 on both sides, and I think we're going to get negative 1/4 for a. So my full vertex form, y equals, I know what a is now, negative 1/4, x plus 4, I saw that early on, squared, plus 2. And there is my vertex form of the parabola that goes through these points. All right, converting to vertex form, completing the square. So I'm going to say y plus 1, leave some room for a plus blank, x squared plus 4x. I'll add my plus blank, and b over 2, 4 over 2 squared, 2 squared, I need to add 4 to both sides. So that means y plus 5 is equal to, what is my perfect square? We can factor that kind of in our head, x plus 2 squared. And so it's basically in vertex form, we just need to subtract that 5 over. X plus 2 squared minus 5. If you're wondering what a is, it is there. It's that invisible 1 in front of the x plus 2 squared. So y equals 1 times x plus 2 squared minus 5 for our vertex form. All right, 17, a couple ways you could do it. And I'll show you the setup for one, but then probably how I would do it. The height h in feet of a certain rocket t seconds after it leaves the ground is modeled by this equation. When does the rocket hit the ground? Round your answer to the nearest hundredth of a second. What is the height of the rocket when it hits the ground? That's the hint. So we know that a rocket has a trajectory, something like this. It goes up, it comes down. And we want to know, when does the rocket hit the ground? The height when it hits the ground is going to be 0. So this is basically saying, find the root. This doesn't look something that would be easy to factor. Completing the square, these numbers are kind of big. It could get ugly. But one method that will always work to find roots, and it's kind of tedious, but we can use a calculator, is the quadratic formula. I could say x equals negative 48 plus or minus square root of 48 squared minus 4 times negative 16 times 15 all over 2 times negative 16. I could absolutely plug that in, use my calculator, and solve. But I might just use my calculator directly in the graphing function. I might say, let's graph negative 16x squared plus 48x plus 15 and ask it to graph. And you can't really see the full parabola because it goes up super high as rockets do, but it looks like it goes up and it comes down. And I think that coming down, hitting the ground, that's the 0 I want. So I'm going to go second calc. I want to calculate the 0. And I'm going to try to, I'm looking for my left bound. It looks like it should be somewhere around 3, my answer. So maybe like right there, that's left of the 0 I want. Enter. My right bound, I'll just go down. That's right of the 0 I want. Yes, this is about as close as I can get. So I'll say, okay, enter. And it tells me that the 0 is at 3.2853571. After 3.3-ish seconds, we will hit the ground. Now we're asked to round to the nearest hundredth. So I will say 0.28. The 5 after the 8 means I should round up 3.29 seconds. And again, you could absolutely get the same answer from the quadratic formula. But with a graphing calculator, I'm just going to use it. I'm going to use it and find that 0. All right, 18, a one variable inequality. Solve this by graphing. So again, I might just come to my calculator and say x squared plus x minus 12. Graph. And it draws it. There's my parabola. I'm going to grab the table and find some things. So -4, I'm just going to copy these down. -4 to, I'll go -4 to 2. So x, y, -4, -3, -2, -1, 0, 1, 2, 0, -6, -10, -12, 0, -6, -10, -12. This said -12, -10, -6. So -4, 0, -3, 1, 2, 3, 4, 5, 6, -2, so 8, 9, 10, -1, -12, 0 is -12, -10, -6. And I want to find, I'm going to go down one more because of symmetry, I have a feeling it'll be another root. So 3 is 0. Perfect. So we know that the graph of this equation looks something like this about. We are asked, if that's the graph of this equation, where is it less than 0? In other words, for what x values is it below the axis? Everything from there to there. Everything in between, it looks like -4 and +3. Any x in between -4 and +3 will end up below the x-axis, meaning it is less than 0. So that right there is problem 18. That's 1 through 18 on the test, pretty much the whole test. There was a bonus problem, which I'll work out just for fun. Similar to problem 9, where we're given 2 roots, but now the roots are imaginary, and we want a standard form equation where a, b, and c are integers. If positive I root 2 over 3 is a root, then that means this is probably a factor. So that when we plug positive I root 2 over 3 in, we get 0. And really similar on the other root, if negative that is a root, then this is probably my other factor. So let's start foiling. X squared plus xi root 2 over 3 minus xi root 2 over 3. So those will cancel. Minus I squared. Root 2 times root 2 is just 2. And 3 times 3 is 9 on bottom. Equals 0. X squared. Remember that this is a -1. So minus -2/9 equals 0. So x squared plus 2/9 equals 0. Only step left, we wanted all integers. I'm just going to multiply everything by 9. I could do that if I do both sides of the equation. 9x squared plus 2 is equal to 0. And I can always check that by pretending, okay, let's say they gave me this and asked me to solve. That means 9x squared, would have to equal -2. X squared would have to equal -2/9. Square root both sides. That means x would equal plus or minus the square root of -2 over the square root of 9, which is 3. X equals plus or minus I root 2 over 3, which is exactly what we were hoping for. So again, this video is not meant to teach you chapter 5, to make you an expert in chapter 5, but hopefully it is helpful when looking at these exam problems to see what went well and what didn't, and what do we need to fix. If you have questions, please reach out to me, but I'm hoping this is a nice overview of those problems on the chapter 5 exam, and I will see you next time.